Welcome to today's video on F-test or two-sample variance test. Let us see one important application of this test. When we are doing a t-test to compare the means of two samples, we have to decide whether we are going to do a t-test with equal variance or t-test with unequal variance. So to decide which of the tests we have to choose, we have to see the result of F-test. So when we have equal variance, that means there is no significant difference in the variance, we can go for two sample equal variance. If we observe a significant difference in the variance, we have to go for t-test unequal variance. In addition, comparison of variance is also important in certain circumstances. Suppose we have a grading system to evaluate 100 students and we have two evaluators involved, then it is necessary to compare the variance in the evaluation of the two evaluators. The assumptions for F-test are the populations from which the two samples are drawn should be normally distributed and the two populations should be independent of one another. The formula for calculating the F value is standard deviation the whole square of one sample divided by the standard deviation the whole square of the other sample. We know that variance is the square of standard deviation, hence this formula. And it is always convenient to have the larger variance in the numerator. In such a case, we will be comparing the right end of the tail, and if we have the calculated value greater than the table value, then we can reject the null hypothesis. To do this test, there are two ways of doing it. So first thing is we can find out the variances of the two samples, because then it is easy for us to decide which variance will go to the numerator. So for that, you can insert the formula is equal to variance. So start with VAR dot for a sample. We are doing it for a sample and we have to feed our data. So this is our first sample, and then close the brackets, enter. So we are getting 99.75. So this is the variance of the first sample. Now similarly we can do for the other sample. So is equal to VAR. So all the list of tests that begin with this we are able to see, dot for a sample we are doing, and within brackets we are going to feed in our data. Close the brackets, enter. The variance of this sample is 129.8. So now the F value, suppose we go for the greater variance on numerator. So 129.8 divided by 99.75, we have found out the answer as 1.3. A value close to 1 itself indicates that the variances are quite close to one another. But if we want to see the table value, so we can go for the table value at the right end. So for that we have to use the formula F dot inverse dot the right end of the tail we are comparing, and what we have to give here is the probability at which we are going. So 0.05, which is generally used in life sciences, and the degree of freedom of the first sample is 10 and the degree of freedom of the second sample is 8, which is n minus 1. So you have 11 here, so the degree of freedom is 10. You have 9 here, so the degree of freedom is 8. So close the brackets and you get the table value. So the table value is 3.34. So the calculated value is lesser than the table value. So we have to accept the null hypothesis, which means there is no significant difference between the two groups. The same F-test can also be done using the data analysis tool pack. In this, the variance that comes in the numerator depends on how we are giving the input. So we will just check for that. So here what happens, if I give this variance first, because I know this is the larger variance, and if I feed in the next sample as input 2, and let me choose an output range to get the result. Instead of a new worksheet, I can choose an output range. So suppose I'm getting my output here. Okay, so I've got my output here. So if you see, we get the means of the two samples and we get the variance. The same thing that we got here, 129.8 and 99.75. The number of observations is 11 and 9, therefore degree of freedom is 10 and 8. And the same F value that we calculated, we have got it here. And the F critical value also, which we saw, we have the same value here. So now our calculated value is less than the table value. So we can't reject the null hypothesis. We accept the null hypothesis and we say that there is no significant difference, which is also reflected by the p-value. See, when we have a p-value above 0.05, it means there is no significant difference. But in case we are using the data analysis tool pack to do the F test, when we don't know the variances of the two samples. So for example, now initially we had calculated the variances, so we knew that which is the bigger variance. In case we don't know that and we are doing a F test. So suppose I feed in this as my first sample and I feed this as my second sample. So let me get my output in a range here so that we can compare. Result here. So in this case, we see the first sample mean is 80, the second sample is 83, just like we saw here, the same variance and the same observations, degrees of freedom, but only thing you have it reverse based on sample 1 and sample 2. Here, the F value which you get is 0.76 because now it divides 99.75 by 129.8. And the left end of the table, left end of the F distribution, the critical value is 0.298. In this case, we can reject the null hypothesis only if the calculated value is less than the table value. So here it is high. So again we have to accept the null hypothesis. So that is the only difference. When we compare the left end, we have to see if our calculated value is less than the table value. And here it is not, so we have to accept the null hypothesis, and the p-value also indicates that there is no significant difference between the groups. So based on the p-value we can decide. However we feed our sample, based on the p-value we can see if there is a significant difference between the two variances. Thank you.